And as part of our Mars weekend now on BBC2, we join Clive Anderson, live on Earth.
Welcome back to a very exciting and excited studio as we await a signal from Mars to tell us that all is well and that the NASA probe Pathfinder has suffered no fatal injuries after one of the most unusual touchdowns in history, give or take a British Lions try in South Africa. Pathfinder is now on Mars, we know that, but until 7 minutes past 10 tonight, we really won't know whether it's in bits or in good shape and raring to go. Anyway, to discuss the mission until then, I'm joined by three very distinguished guests. The first, well, no evening like this will be complete without the man who more or less invented space as we know it, Patrick Moore. Then from the Natural History Museum, a geologist who has been at the heart of the debate about life on Mars, a woman into every kind of rock from iron pyrites to Led Zeppelin, Monica Grady. And finally, a man who knows more about Martians than Martians do themselves, since they probably don't exist, the co-editor of the Encyclopedia of Science Fiction, John Clute. For those of you who've just joined us, you're late, but let's take a look at the events that have happened earlier today. And these were the tent scenes at NASA's Jet Propulsion Laboratory in Pasadena earlier this evening, just before Pathfinder landed. During the landing, Pathfinder sent back a signal which lasted a few minutes after touchdown. The purpose of this was simply to tell Mission Control that Pathfinder hadn't been destroyed during the dangerous entry and landing procedures. What it hasn't told us is whether everything has arrived in working order and ready for a fortnight or so of running around the surface of Mars, taking photos, sending messages home, and generally acting like a tourist. There you go, though. As you can see, Mission Control at JPL were extremely relieved at around 6 o'clock this evening to receive that first signal telling them that so far everything was going well. Now, in the 3 hours since then, the airbags surrounding Pathfinder have deflated, and the petals, so-called, surrounding the little rover have opened up and allowed the probe to cool down while it waits for dawn to break on Mars. Oh, there, we've even got pictures of dawn breaking on Mars, what it might look like. Now, the Mars landing site is roughly on Bangkok time for some reason at the moment, and so the sun should be rising any time now. Once the sun's rays hit Pathfinder's solar panels, it will wake up, give itself a quick health check, make sure it hasn't got any broken limbs or short circuits, and then it'll be send the really important signal, the detailed report that Pathfinder is fit and well and ready for its first full day's work on Mars. Either that or it'll phone in sick. Now, we're expecting its message at 7 minutes past 10, but as you will have seen in the Horizon documentary earlier, unless you switched over to Channel 5, stranger things have happened, this isn't the first time we've landed probes on Mars. I say we, somebody's landed probes on Mars. There were two hugely successful probes in 1976. The Viking landers gave the first ever images from the surface of Mars, as we can see from these pictures. But apart from the panorama, Viking also ran tests on the Martian soil, and that was some 21 years ago. So, Patrick, now we've got this mission, 21 years on. How is this different? Is this any further forward?
Oh, very much so. After all, remember, the Vikings simply came down and there they stayed.
Yes.
And now this, the rover from the Pathfinder should move around.
Yes.
I'm sure that over at the JPL at the moment, the atmosphere is almost unbelievably tense.
So there's a good atmosphere there. There's not much of...
Some of these things work, some that are Mariners 1, 3 and 8, they don't work. It is very tense. Yeah. And of course, an immense amount of testing has gone on. And looking at some of the records of that testing is quite amazing.
But nonetheless, this is quite a cheap mission, really. It only costs $150, $200 million, which is... You'd spend that getting to something which might or might not be Van Gogh.
About a quarter of a nuclear submarine?
Yes. No, but what are we going to find from the geological point of view, Monica? What's just by looking at it, are you going to tell very much about the the rocks that are there?
Well, we hope so. The site has been chosen very carefully to be at the mouth of a river valley where there should be a range of rock types from the highlands. There might be volcanic rocks, there might be rocks from just below the surface, there might be sedimentary rocks showing sort of stripes as if they've been laid down in the river. So even
fossils, if there happen to be any, but
maybe.
They're talking us down. That's what we want to see, some fossils.
You know,
From
probably
a science fiction point of view, this is all far less small beer, isn't it? Now, because this rover, the best we can do to illustrate what it's like, it's a bit bigger than that, not much bigger in size, and it's a lot heavier, but it's not much bigger than that, is it?
Not a lot, no. Not the size of a large television set.
Yeah. So this is what's right. Now, we've seen Star Trek and Star Wars, even Doctor Who had better props than this normally. So is this a bit disappointing from the
If it is, I would be personally disappointed in the person who was disappointed.
Yes.
Because what we have here is not a story, not a prop, but for the first time a vehicle which moves on Mars.
Yeah.
And we have it significantly very, very cheap. In a sense, it doesn't matter nearly as much if this one fails.
No.
Because it only cost $150 million.
Oh, right, so we just order a new one.
And there are others in the pipeline.
But this is going to wander around, and it's only destined to last about a week or 2 weeks. Now, that's a short time, even for a rover in the British Leyland days. So couldn't it last a bit longer than that to get more?
It almost certainly could, I think. But on the other hand, don't forget, if it's going to succeed, it'll do so pretty quickly. Yeah. And the most important information will come back pretty well straight away.
Yes. So what's going to happen, though, after a week or two? Why is it going to stop?
It'll run out of power. Yeah. And after all, it'll simply stay there until someday someone's going to go up there, find it, and cart it away to a Martian museum.
But it's got solar panels to power it.
Oh, yes.
Or are they just not fitted batteries?
No, it should be powered up for some time. Yeah. And these experiments very often last longer than intended to do.
But so if it's got solar power, why can't it go on forever?
Simply, well, the Martian night is very, very cold, more than minus 200 degrees, and it can't survive that very long.
So it'll freeze its solar panels off.
It will indeed.
Yes. All right. And it doesn't go very fast, does it? It goes...
No, about 20 meters per hour. I think it is something very, very slow indeed.
Yeah. So that means it's not going to cover a huge amount of ground.
It won't. It won't cover a very wide area because it can't go very far away from its landing point. Otherwise, contact will be lost. It's a very restricted thing, but the point is it will move around, and it will show that this can be done.
Yes.
This, after all, is very much of a pioneering mission.
Yeah. And we're going to see in a moment how this is done, but is this going to be enough to be able to find enough different rocks to make a meaningful inquiry from your point of view?
Oh yes, should be able to, because as well as having the solar panels on it, it's got a little sensor which will move up and actually move against a rock face and take a composition and measure the chemistry of the rock, and so it'll go say, right, okay, that one's a green one, move on to that one's a red one, that one's a blue one.
Okay, we're going to hear a bit more about that, because the rover is clearly the key to making this mission different from the others, and the first pictures of the rover on the surface of Mars won't be sent back until early tomorrow morning, and you'll have your first opportunity to see them on Open Saturday with Patrick Moore at 8 o'clock tomorrow morning. So he's going to have to dash off and get a good night's sleep after this programme. In the meantime, just how do you control a vehicle when it's 130 million miles away? We have now the first of our home videos from Mission Control, bringing insights into the day-to-day problems of landings and operating a probe on Mars. Now, this will be done by Brian Cooper, so perhaps it ought to be called not a rover, but a Mini Cooper. He's the man who's actually going to be driving the rover, and it kicks off with a driving lesson on Mars.
Hi, my name is Brian Cooper, and I'm the rover driver for Mars Pathfinder. Today I'm going to show you how we're going to tell the rover where to go on the surface of Mars. Take a look over here, and we have a screen, and I have 6 images from the lander cameras, and what I'm going to do is move this icon of the rover. And most of you have had a good experience maybe playing with a radio control toy car, and you think that's how you probably want to tell the rover how to go, but it doesn't work that way. The problem is it takes 10.5 minutes for the signal to get from Earth to Mars. So say if I were to tell the rover where to go with my joystick here, and if I give it a command to go to a certain location, like say out here, by the time that signal gets to Mars, it's going to be 10.5 minutes later. Similarly, if I get pictures coming back down from Mars, they're going to be 10.5 minutes old. So it won't work. What we need to do is make the rover smart, and smart enough to go where I tell it to go, but do it safely, so in case I make a mistake and accidentally tell it to go over a cliff, it won't do it. See the rover here? I can move that off the pedal onto the surface And if we like where it is, we can click a button and leave an icon for a waypoint. This is where we want the rover to go. And it's a nice clear spot over here. Let's tell it to go over here. And let's say we want to go to this pile of rocks on the right. And this would be where we want to go. At this point, we would tell the rover to spin around and take pictures of the rock that we have that's behind it, and then spin around and place its sensor on it and figure out what the rock is made out of. The rover itself has a sensor that can tell if it's tipping too much, and if it senses that, it knows maybe it shouldn't go any further in that direction. It'll go around the obstacle and still try to get to the goal. What we did, we took images from the lander and we processed them, and we're able to put on these special goggles. I'll put them on right now, and if I do that, I get this extra sense of depth, and I can see into the screen in 3D. And now I can get up real close to one of these rocks and see what the shape is, or look at it from an overhead view. So let me do that. I want to look at this rock a little closer. We'll zoom it in, and we can see that it's got an interesting shape, and maybe because of the shape that we can only tell in this viewpoint, maybe we'll want to go there. Eventually, we can get so far away from the lander, if we want to, that we can't even see the lander anymore. The lander can't see us. When we do that, then we'll be navigating from the viewpoint of just the rover cameras, which is a lot lower, so it'd be like somebody crawling along the ground, and everything's going to look more like a maze. And the last time they did a test, they tried to pull a trick on me and see if I'd noticed, but they put a potted plant on a rock, and we don't expect to see a potted plant on Mars, but that'd be pretty neat if we did. During our testing, though, it was there just kind of as a fun thing that they did to trick me.
Well, I think I understood that, but why doesn't my mobile phone work 90% of the time? It's, just trying to communicate with a transmitter just down the road. Anyway, but whereabouts on Mars has this rover landed? The real question is that nobody knows exactly. The landing area has been carefully chosen, but the exact spot remains a mystery until we get some information back later on tonight. In fact, Pathfinder could have landed anywhere in an area that's supposed to be roughly the size of Cornwall. Now, that sounds a little bit casual. You know, when we're bombing people in the Gulf War, we knew just exactly where Saddam Hussein was having his barbecue.
Yes, but the Gulf's a bit closer than Mars. I mean, you're dealing with a distance now of more than 120 million miles.
Yeah.
So I think it's not bad, you know.
No, and I suppose it doesn't really matter, does it, if you just want to hit Mars?
Well, not really. They come down in this general area of Aries Vallis, which is an old floodplain, almost certainly.
Yes.
And, of course, we haven't got the actual isolated rocks there.
No.
So really, it's a certain amount of potluck.
Well, I've got some pictures here, which I hope demonstrate something. That is a picture of Mars, as you can tell, and there's a problem with a possible storm developing. Sorry, I'm getting last-minute instructions coming in from Mars there. Now, I'm not sure these pictures do show very clearly with a storm, but there is a picture. This is the Aries Valley, which is landing on, and the landing site is somewhere up there, and there's a storm building up there. Now, we learned about the Viking mission that rather mucked them up.
Well, in point of fact, the dust storm is not there. It's some way away near the Valles Marineris. Yeah. And, of course, although the wind speeds may be high, the Martian atmosphere is extremely thin. Yes. Don't forget, it's mainly carbon dioxide, and the ground pressure is below 10 millibars everywhere. So I think there's no danger at all. It'll be toppled over. The danger, of course, comes from dust being deposited on the various equipment.
And it could engulf our little rover thing.
Yes,
but you've actually got some rock from Mars already, haven't you?
That's right,
I've got it there. I'm being very careful with it. Now, how did you get that? How did we have that bit?
Well, that didn't cost us any number of millions of dollars at all. This one came for free. It's a meteorite, and it was blasted off the surface of Mars by an asteroid that came down, bumped into Mars, and shot the rock off. And this particular piece of rock fell in the village of El Nakhla al-Bahariya near Alexandria in Egypt in 1911.
And what happened to it when it landed?
It allegedly killed a dog, one of the shower of stones. So it's a very, very special thing.
I bet somebody was looking after the dog at the time, because their dogs' pets always die when somebody else is looking after it. So, well, there was this dog, and I had it out, and a meteorite killed it.
The rock came from space.
So that's a lot cheaper than having to send something there yourself, if they're just going to shower rocks down on us.
That's right, but we can't rely on it. We can't predict when and where they're going to fall. We can't predict that they're coming from Mars, because most of them come from the
And can you be certain that actually did come from Mars and not just from a tower block down the road?
I can be certain this came from Mars, because gases trapped in rocks like this contain samples of the Martian atmosphere. As Patrick said, the Martian atmosphere is mainly carbon dioxide. It's very different from Earth's atmosphere. So by melting bits of this rock and taking the atmosphere out, we can see that it's definitely come from Mars.
Oh, well, we'll come back to that. But now, one of the reasons that NASA chose the Ares Valley for the landing site was because it had reasonably good weather. And I've demonstrated the photographs to you already, such as we could see. Mars, as we saw early on in the evening, can be prone to violent winds and dust storms, and recent images from the Hubble Space Telescope, however, have been a cause for concern. And the latest images do suggest that there is a sandstorm around, and it started blowing less than 600 miles south of the landing site in the Valles Marineris, which I think you pronounced rather better than I did, Patrick. Canyon. Now that's a canyon that would run from New York to Los Angeles, and it's 6 miles deep, so quite a grand canyon in itself. And it was a similar dust storm, which preceded the major sandstorm of 1976, which covered the entire surface of Mars just as the Viking probes had arrived. On the other hand, the same images show that there are thick clouds looming just to the north of the landing site, and this hope that these will keep the temperature down and reduce the risk of a major sandstorm. Nevertheless, with wind speeds of 80 miles an hour, a sandstorm would be pretty damaging to the fragile rover. I mean, you seem to say, well, it wouldn't be too bad. But,
well, I don't think it will. See, the atmosphere is so thin. And after all, the winds are going to be only 1/100th the strength of Earth winds at the same time. Now, I think the main danger there is that the dust may actually cover the vital parts and possibly cut off the solar panels. I don't think it will. This is not really a major dust storm anyway. It's some way away. I must say, from my observatory, I looked at Mars a couple of nights ago, and I would have seen anything major with it, and I didn't.
You'd have told them and said
certainly.
They could have a blower on the front of it just to blow some of the dust away, just to keep it a bit clear. All right. Now, so we know something about the landing site. Just now remind ourselves of what Pathfinder went through in order to get there. In the second of our home videos from Mission Control at NASA, Flight Commander Rob Manning explains the perilous landing sequence that Pathfinder underwent just a couple of hours ago.
Where I am right now, this is actually an area where we actually test Mars rovers and landers. This is called the Mars Yard. And the nice thing about this place is that it's built exactly to represent what we think Mars looked like at the Viking 1 and Viking 2 landing sites from 20 years past. So this is what we think Mars Pathfinder is going to see when it gets there. The drama of landing, unfortunately, cannot be seen by any of us. First of all, it's nighttime. But secondly, there's no one there to see it. Well, a few hours ago, the space capsule hit the upper atmosphere of Mars at 7.2 kilometers per second. Incredibly high speeds in a long trail of flame as the heat shield absorbs the energy of that deceleration. Shortly after that, a parachute opens up. The parachute does a great job getting us down to about 120 miles an hour. That's the best they can do. And our airbags that protect the lander when it hits the ground for the first time cannot handle those kinds of speeds. So we have to stop this whole system mid-air, some 45 feet above the ground, with these solid rocket motors, which are lit at the very last instance, just before it hits the ground. So Mars will get this bright, blinding flash of light, lighting up the scene. And from there, these giant 17-foot diameter bags hits the ground, and it will sail. It will go for at least 100 meters per bounce, hitting this area and bouncing, sailing clear over to that building way over there.
It's going to stay in one piece?
Oh, yes.
Right. Now, I mentioned in the introduction, Patrick, that you invented space, but of course that's a little bit of an exaggeration. We all know that Galileo invented space. But you have been around a long time, and you made a name for yourself in astronomy before space flight was possible. In fact, you did your first TV the same year that Sputnik was launched. And sorry, it's sounding like this is your life, but did you ever expect you'd get to the day when you would see, or we'd be able to see, little creatures, or at least little rovers, wandering around on Mars?
I thought I would. On the other hand, my time scale was wrong. That's it. I was expecting the first men on the moon by about 1980, and of course it was 1969. Yeah. My time scale was definitely too pessimistic. I knew it would happen, but whether I would see it myself, I didn't know. I only hoped so.
So this is going better than you thought?
It's going certainly much faster than I thought it would, yes.
Well, we've got 5 minutes, something like 5 minutes, just over 5 minutes, to when the point should come when we get the signal to say it's all right. If it doesn't come, all is not necessarily lost.
No.
Makes a rather drab moment in this programme, but they could possibly give a signal later with...
the high-gain antenna, which will open just after 1 o'clock this morning.
Yes, and they can't switch those on immediately.
No, they can't.
Well, why is that? Do they need more power for that?
Yes.
Right. Okay, well, I guessed right. Well, just to show the problems that planet and stargazers had from Galileo's time right up to the space age, here's a vintage clip from the sky at night in the very early days, featuring a familiar face.
Wasn't meant to be a comedy show, it turned out that way.
Well, of course, when we come to this kind of thing, we are rather dependent upon the weather. In fact, we're entirely so, because if you have clouds, there's really very little you can do about it. George, what do you think of the prospects now at the moment?
I think we're nearly totally obscured, Patrick.
Do you think it's any good turning onto the general direction of the moon? Frankly, I don't think it is. I can't see a single star at the moment.
It's totally obscured.
We were hoping to see Vega, which is the star, bright star straight above our heads, but even that's gone now. No, we've got to abandon it for a moment.
We're blacked out.
If we can see one star, we'll just get the telescope onto it and give you at least a direct picture of that.
No, we are totally obscured.
Well, there's hope yet. We still have some minutes.
I can see Altair.
Can you?
But it's gone again. It goes before you can get near it.
Well, Altair seems to be about the best bet. I suggest you turn the telescope onto Altair, and just as soon as we get any kind of a picture at all, we can feed it through, so to speak. Any luck?
No, I must be able to see it before I can get onto it.
Trouble, of course. This, of course, is one of the hazards of astronomy. There's just nothing one can do about it at all. There is definitely a lightning over there now, George. Can you see it? It's coming out. Yes, there is the moon. I can see it for the moment. No, it's gone again.
It's gone?
No, infuriating. There's nothing one can do. George, can you see anything at all?
Vega!
Can you see Vega?
I don't know whether I can get on it.
Right, the star Vega, which is the thing we wanted to show you. It's a bright blue star right above us, as I said earlier on, and with any luck now, we will be able to get the telescope on it. I can see it quite clearly, and I think we're just about going to have time to show it to you. But, of course, there's still a lot of drifting cloud up there, and we just can't tell whether it's going to be obscured at the critical moment. Of course, you won't see Vega looking large, because no telescope yet built will show a star.
It's gone,
Is it gone?
Just as I got it on the crosswires, it blacked right out.
How absolutely typical. There's nothing we can do about it.
I can't move a 24-inch telescope quicker than that.
No, I'm afraid you can't. So, from Brighton, where the sky is now completely overcast, good night.
Good night.
1957.
I recognise the familiar sound of somebody filling in as you're desperately waiting for something to happen.
Frantic padding.
But everything else has changed apart from your suit, which I notice is exactly the same.
The same one, probably. I may say, both 5 minutes before and 5 minutes after that 20-minute live programme, the sky was brilliantly clear.
Right. Jolly good. Well, we think 2 minutes away from getting some sort of signal that the thing has landed and is now signalling to us. But Monica, if you just tell us where this little rover is sitting there waiting. Has this spot been selected simply because it's the least dangerous place to bounce to a halt, or because of the attraction of the rock site?
Because of the attraction of the rock site. It's in a place called the Ares Vallis, which is flat area, about, 200 by 100 kilometres, I think it said.
Yeah.
And it's at the mouth of a river channel. It's flat. It's showing a lot of different variations in rock types will be there. Yeah. It's believed that the Pathfinder has actually landed on a raised island in part of that valley, right, where there should be a fair amount of different types of rock.
Well, you say it's a river valley, but the river would have flown there, what, millions of years ago?
Oh, absolutely, millions of years ago. Yeah. And there's no trace of water there now. No. And not so much a river valley, more a delta, more a sort of catastrophic outflowing where rocks would have been swept down from the highlands. And that's another reason why it was chosen, because it's sampling highland area, whereas Viking did not sample highland rocks. Right. So this is what we're hoping. We're going to get a different type of rock from the rocks or from the soil that Viking sampled.
Yeah. And what we'll be able to tell about it from just this little thing going up and looking at it is it's obviously getting 3D pictures, but will you be able to say, oh, that's the sort of rock that we have on Earth, or it's something completely unusual?
Yes, I mean, this rock that I have here is a basalt. It's formed in the roots of a volcano. We're hoping perhaps that the type of rocks that Pathfinder or that Sojourner is going to look at will have a composition similar to that. They're rocks that have been brought up from a volcano and cascaded down and then weathered by water and then rushed down this channel. Right. Also, there might be sedimentary rocks laid down in water, which have been brought down by the same stream and jumbled together.
Okay, we're going to, sorry to stop you there, we've got to zoom over to Pasadena. Yes. Has a jolly sound to it, and we should see some pictures of the crew waiting to get this signal. 12, 11 seconds to go. Looks like the front office of a sort of accountancy firm, but they'll get excited. That is Bob Manning. Yes, he's the guy in the beard, as we saw earlier on. He's the control of the whole thing. Oh, he's gone off, maybe a bit nervous. Has to pop out for a moment. Oh, now this should be the time then. We're waiting for them to whoop up.
We have the closed-loop receivers in lock and carrier.
Oh, that looks... Yeah, that's it. We have the signal. It's a very scientific way to work these things out.
The expected power is within 1 decibel.
This is why this couldn't be a British mission, because the British will just go, oh, that's it then, that's fine. But Americans do at least sort of go, oh.
We expected the actual data from the spacecraft.
Okay, we happy with that? While they celebrate in a controlledly wild way. So, so this is a great relief for everybody, Patrick.
It looks like it. I mean, don't be too cocksure yet. I mean,
no,
don't quite know whether we're going to get any pictures back.
I'm never cocksure, if at all possible.
It looks good.
Yes. Well, what can they do if it turns out not to be right? They'd have me sort of start putting thumbs down or something like that. So what are they going to be looking for next? We've got the signal to say it's ready.
We've got the signal to say the petals have opened, it's being able to point its antenna at the sun, it's being able to direct itself. They're now going to decide whether the low gain antenna has unfolded, whether that's all right. They'll decide whether to deploy the high gain antenna, and they'll make decisions in an hour or so's time whether the ramps should come down, whether Sojourner will go out, and the first pictures will be coming back in an hour or two's time. So this just means at the moment that the petals are folded back and that the mast has gone up.
So you've been in a lot of these mission points when there's a lot of tension building up to whether it's going to happen or not. I mean, does everybody sort of job on the line as to whether it's going to work, or would they have just done another one?
No, they were. After all, you say this by space standards, this has cost a lot less than some of the earlier ones. And as you say, if it doesn't work, it is a pioneering mission. And I think already, although we know it's landed there, and this very complicated manoeuvre, we know it's landed. We know the petals have unfurled. So even if nothing more happens now, and I think you will, but even if nothing more happens, you still can't write this off as a total failure, even so.
No.
I think it may be a total success.
Yes.
But already we can say that it's proved its worth.
Yes. And, I mean, do you think this is now fitting in with, you know, H.G. Wells would be pleased to see that we've got as far as Mars?
He'd be enormously pleased. He'd be enormously pleased at the fact that we're no longer telling big stories about Mars. We're beginning to tell little stories that work. It's terribly, terribly important that these missions continue. Not that the whole thing depends on success or failure of one enormously expensive, obsolete mission.
Yes. So this represents a sort of revival of the whole space program compared to, there's been a few hiccups, haven't there, the last decade or so.
Absolute revival. Absolutely.
This is called Pathfinder. I mean, it is a Pathfinder. It's providing information for other missions that are being planned. It's providing information about the surface of Mars for the Surveyor mission, which is coming.
All right, well, let's go on to the future, because over the next week or two, the rover will wander around as much of the surface of Mars as it can manage, photographing rocks, poking around in crevices, and doing some simple analysis. And this should tell us something about the geology of Mars and arguably about the history of Earth. This is fantastically exciting for geologists and astronomers, but it's unlikely to answer the question that the rest of us are perhaps more interested in: is there or has there ever been life on a planet other than Earth? Now, last year, NASA announced the possibility that there were signs of life in a meteorite that had come from Mars, which has the snappy title of ALH 84001. Now, one of the experts who examined the meteorite was Monica Grady here. So do you think there is evidence in it's not this meteorite here, but another one. Was there evidence found in that to show that there was life on Mars?
Sadly, no. Well,
some people seem to think, because there's little things that might be tiny bacteria.
All right, the jury's still out, but most scientists believe that the structures that were described by the scientists from NASA are simply crystallographic features that they interpreted as biological, where they were totally inorganic. What the rock did show, however, was that there were salts, that there were crystals inside that rock that had been laid down in water at a reasonable temperature for life to have existed. So the environmental conditions were right on Mars, and that's what that rock showed. It showed that life could have survived.
So little wormy shapes were not worms, they were just crystalline structures.
That's what I believe, and that's what many scientists believe.
Yeah. Well, it's exciting. I mean, I think it's fantastic exciting getting to Mars, But in a strange way, space isn't, the planets aren't turning out to be quite as exciting as we thought they were going to be. We're not finding creatures or even slime molds or anything there, or just something. So do you find this a bit disappointing as we actually make the landing?
No, I don't really. I might if I was, say, 17 or 18. But
and you must be at least 5 years.
Oh, I'm at least 5 years
yes.
older than that. And I find that the stories about Mars or about the solar system or about the galaxy are great fun to read.
Yeah.
But we know they're stories. We know they're not true. Most of them are pretty old.
We know that now, but somebody writing a story 100 years ago could imagine there to be life on Mars, and it was at least plausible, as possible. There might have been vegetation, there were patterns. Somebody even thought there might be canals there, or at least a
Wells made use of this Percival Lowell's invention of the canals on Mars by mistranslating Schiaparelli's channels.
He described canali in Italian, and that was translated as
good enough for canals.
And we imagined the Irishmen there digging it for us.
And in terms of 100 years ago, it was a perfectly good hypothetical idea.
Yeah.
But we know now the story is just as good as it ever was, but we know it's not based on a real Mars.
And there could be life on any number of planets which might be anywhere in the universe, but they're all billions of miles away that you can't get to.
The terribly thrilling thing about the trailing of this possible life last year was that if it turned out to have been true, it was probably the most important story we could have ever heard. Yeah. Because if two planets in one solar system independently generated life, that would have meant that there were, of course, trillions of planets in the universe that had generated life, almost certainly.
So what we really want is somebody to pick up this rover and shake it around a bit, and then we think, now we have a story.
We would have the story. Yeah. I'm not sure we would like that story, because that story would be a science fiction story, and it would be melodramatic, and it would not be particularly beneficial to our egos.
Okay, all right. Well, we'll find out over the next week or so just how successful Pathfinder will be. But without taking anything away from the rover, I suppose the mission that everyone wants to see is the first astronauts on Mars. Now, according to the documentary Mars, Death or Glory, which is tomorrow night on BBC2, the round trip for a manned expedition to Mars would take about 3 years, with no real guarantee that the astronauts would ever come back alive. Surely only a lunatic would consider such a trip. Well, British astronaut Commander Mike Fole is at this very moment circling the Earth on the damaged Mir space station. He's one of NASA's most experienced astronauts, having made 4 trips in space, including this dramatic spacewalk. Despite his first-hand knowledge of the perils of space flight, it remains his dream to be one of the first men to walk on Mars. Just before he left for Mir, he was interviewed for Death or Glory and asked what he felt about the risks associated with traveling millions of miles to another planet.
And so when you ask a man who has a young family and a wife, are you willing to do that? He has to really come to terms with this. And I'm not at that point yet. Luckily, I'm not being asked yet. By the time I'm older, maybe my relationship with my wife will be such that I could do this. Maybe my wife will be in a position that she could do this with me. Because when you're sending people for such a long period of time to Mars, you're not dealing with just skill mixes, randomly throwing people together and saying, get on. You need to come up with groups that can live together as a family, basically. And so maybe it's appropriate to send spouses with astronauts. My wife happens to be pretty well qualified in that area anyway. So that's how the daydream goes.
Well, we were hoping to speak to Mike this evening, but unfortunately, as you may have heard, a bit of bad parking on Mir has meant we can't get in contact with him. But do you think that's the most recent of these accidents? Do you think this Mir accident has put the mockers on manned flight going towards Mars? We're all shaking your heads.
It's certainly a hitch, no question about that. But it's a blip. It's a major one, obviously. It may delay things a bit, but it certainly won't kill it. Oh no.
But in order to get to Mars, as a 3-year round trip, you've got to put up with radiation, which might cause all sorts of problems, the possibility of crashing, and obviously testing everything to the limit. So
human body could be the weak link, of course, and one thing you can't do is to turn around and come back. Yeah. After all, they had the near disaster with Apollo 13, and they couldn't go around the moon and come back ahead of time.
That's peanuts going to the moon, so it now turns out. Going to Mars.
Because Mars is a different matter.
Yeah. Well, so would you like to go? Would you volunteer to...
I would like to go, but you need a very massive rocket to launch me.
Well, you're bigger than the rover, but...
I'd love to go, yes. Yeah. I'm a little ancient now, I'm afraid.
Yeah. But... Sorry, are you volunteering as well, or is this just...
I would volunteer, certainly, but I was thinking about something else. I was thinking about the Mir. And the Mir is almost, in a sense, the last of a long line of big rockets, a kind of, in a sense, the wrong story of the exploration of space.
Yes.
The story of huge lead time between developing a rocket and sending it off, so that it's guaranteed to be obsolete before you send it up.
Well, you need a big rocket. You can't just have a milk bottle and a sort of thing.
I don't know what in 15 or 20 years we're going to need, but I don't think we're going to need these great archaic creatures in space. I think we're going to have to move in the direction that the Pathfinder demonstrates.
Yes.
That we're going to have to move towards a short lead time, so that by the time we send the machine up, it's not already obsolete.
Yes.
So that we can do a variety of things with it, and if it breaks, we can send something else. The space flight of individuals is terribly important symbolically, but perhaps less important than some of the other ventures.
And this little Pathfinder landing, this is part of a more structured plan.
Exactly.
The trip to the moon was just to prove that we get to the moon.
It was Cold War, it was politics, and this is far more exciting because it has a future to it.
And are they building on the stuff they had from the Viking missions, or is that kind of...
Yes. They're leaping way ahead of the Viking missions.
And are you also volunteering to go on one of these trips to Mars, or are you happy to have it come back to you?
I'd rather stay behind, I think, and analyse the data as it comes back.
So we can sort of not pat ourselves on the back because we've done nothing but sit here and talk about it, but we can pat this mission on the back, in that they've got the little vehicle there, and it'll be showing you pictures tomorrow morning, Patrick, and anybody who cares to look in.
Well, we can't be sure yet. I say it's too early to be absolutely confident, but I think the outlook is good, and I feel a great deal happier than I did when we went on the air for this program.
Well, so do I, but for different reasons. So, for those of you who missed it earlier, the news is that NASA's Pathfinder has landed successfully on Mars. After one of the most daring landing procedures ever attempted, Pathfinder dropped to the surface, bounced along for about a mile, before it eventually came to rest at about 6:08 this evening. And this was the scene in mission control at Jet Propulsion Laboratory when they heard the first signal that told them that so far everything was going to plan. Can't be certain yet. At that point, Pathfinder literally went to sleep, more or less literally, for a few hours to cool down and to wait for sunrise before it sends back a more detailed health check. At 10:07, JPL started receiving the first detailed information from the Martian surface since the Viking mission in 1976.
The expected power is within 1 decibel.
Oh, there it is. That information will tell the scientists at JPL exactly what condition Pathfinder is in. About 1 o'clock in the morning, it'll be sending back the first pictures, and they'll show the rover and its petals. And from those pictures, they can work out how best to get the rover down onto the Martian surface. From then on, it'll spend a week or so wandering around Mars, sending back images of Martian rock, Martian dust, but probably not Martian little green men. Well, that's about it from us. We leave you with mission control at JPL in good spirits, but the Mars weekend doesn't stop here, and we've just got time to tell you about the rest of the programs lined up for the next couple of days. All this information is available on the Mars Weekend website, and the address is coming up immediately after this program. Immediately after the program, there's What Have the Martians Ever Done for Us, which in the words of BBC's favourite alien is just a bit of fun. Don't forget that if you want to see the first pictures from the surface of Mars beamed back by the Pathfinder, Patrick Moore will be unveiling them on Open Saturday, 2.5 hours of views and analysis starting at 8 o'clock tomorrow morning on BBC2. And tomorrow evening, Mars, Death or Glory looks ahead to the first manned mission to Mars, followed swiftly by Fear of a Red Planet, about the Martians we love to hate. And moving on to Sunday, and at 5 to 9, there's the no-nonsense Natural History of an Alien, the BBC's Natural History Unit, examining the fantastic forms that real aliens might take. And if this whole event has whet your appetite for this mission and all things Martian, don't miss our website at www.bbc.co.uk/science/Mars. It's packed with that address and with information about the weekend, the weather, the gossip, the pictures as they happen, and the chat rooms where you can talk to experts about everything from sunsets to life on Mars, quiz a real Martian. Many thanks to my guests this evening, Patrick Moore, Monica Grady, and John Galut. Before we just go, let's have another look at those shots from NASA's me, Clive Anderson, saying good night. Good night.
For years, third-rate filmmakers have pondered over